Unlocking the Secrets of Galaxy Distance, Part 3, Women Enter Astronomy. Henrietta Leavitt discovers the key to find the distance to far-off galaxies. We measure distance naturally when driving at night. When a driver is looking at oncoming headlights, the brightness of the light tells the driver approximately how close the oncoming traffic is to her car. How can this method work with stars? In her work with the glass plates of stars, Henrietta Leavitt became fascinated with stars with irregular pulse in brightness. They are of the type discovered 100 years previous by John Goodricke in the constellation Cepheid. These stars get brighter and dimmer in a regular pattern. To find stars that pulsed, Henrietta Leavitt would lay 2 glass plates of the same sky view, photographed on different nights, one on top of another. Then she compared the brightness of each star with the same star on the later plate. She looked for stars that had changed in brightness. For most stars she noted, the brightness did not change. She discovered a few stars that did change significantly, brightening and dimming over and over. She called them Cepheid variable stars, after the star in Cepheus found by Goodricke. In her lifetime, she found 2,400 variable stars. Leavitt found that the only information that could be observed from these variable stars was luminosity, how bright the star looked, and period, how long it took to change from dim to bright and back again. Miss Leavitt looked for a pattern of some sort. She noted that there were Cepheids in many parts of the sky. She wondered, how could this regular pulsing of Cepheid variable stars be used? Was there a way to look at these pulsing stars side by side? A bright Cepheid variable could be a close-by, dim star, or a very bright, far-away star. How could you tell what it truly was? Leavitt changed her star field to the small Magellanic cloud, photographed by the Harvard team in Peru. Although no one knew it at the time, the small Magellanic cloud is a small galaxy that orbits our Milky Way. It is seen in the southern hemisphere. Because these stars were close together in the sky, like a distant flock of birds you might see on a walk, Miss Leavitt understood that they must be much closer to one another than they were to the Earth. She could assume that they were all about the same distance from the Earth. Using photographs, she found more than 1,000 Cepheid stars in the Magellanic Cloud. Leavitt measured 25 representative Cepheids. She created a graph of the 25 stars and their relationship. Her graph is represented here. There are 2 parallel patterns, maximum and minimum brightness for each of the 25 stars is compared with the time it takes for the star to change from brightest to dimmest. This is its period. Looking at these stars, she found a clear relationship between brightness and period in the Cepheid stars. The brighter the star, the longer it takes to change from dimmest to brightest. The period is the time it takes for a particular Cepheid star to change from brightest to dimmest. Miss Leavitt discovered that the longer a Cepheid star takes to brighten, the greater its true brightness. If an astronomer knows the true brightness of a star and how bright it looks, she can find its true distance. Excited? You bet. Edwin Hubble used Leavitt's principle to find the distance to other galaxies. This is the Andromeda Galaxy. The black box outlined here shows the area photographed by Edwin Hubble himself. You can see the picture following the yellow arrow. This picture, taken in black and white, was made in 1923, and in it he sees 2 nova and a variable star. Here's where that box is in the picture of the entire galaxy. It's this variable that gave him the distance to the Andromeda Galaxy. Years later, the Hubble Space Telescope, named for Edwin Hubble, observed a close-up of the pulsing variable shown in the box. Look how small it is there in the circle. The distance to the Andromeda Galaxy is 2.5 million light years. For the first time, we know that there are galaxies beyond our own. This method is used to this day. This galaxy, NGC 3972, contains a good number of Cepheid variables. Comparing the brightness of these Cepheid variables with Cepheid variables in our own Milky Way galaxy, we can find the distance to this galaxy. NGC 3972 is 65 million light years from Earth. And look around it. See other galaxies here and there in the distance? Teaching man his relatively small sphere in the creation also encourages him by its lessons of the unity of nature, and shows him that his power of comprehension allies him with the great intelligence overreaching all. Annie Jump Cannon, Computer.